All right. Good morning. 早安. 我是美国人. What else do I know? I think that's it. Thank you for coming and welcome to our Interop Plugfest event. My name's Rob Williams, and I think I know how to say that in Chinese, but I'll skip that. I'm the program manager for the Remote Effects Partner Ecosystem. And what this means is that my responsibilities are to work with our hardware and software partners who are building remote effects devices and servers. So my partners are companies like HP and IBM building servers, NEC, then also semiconductor companies like Intel and AMD, NVIDIA, but also I spend most of my time with our thin client partners, companies like HP and Weiss, and many of the Taiwanese companies that are building thin clients. ODMs like Clientron, but also thin client companies like Atrust. And my role is to really help people understand what we're doing in Windows and to provide resources for you to develop your own thin clients. Most of our remote desktops end up being driven by or connected to by thin clients that are Linux powered or powered by smaller embedded operating systems. So it's I'm really fortunate that I was invited to speak with you today. And we have with us, thank you, Murray. And we also have people with us that help us a lot when we're talking to thin client partners. Guys like Brian Wave, and helping thin client partners developing RDP. So I guess before I get started, I'm curious to know a little bit about the audience so that I can maybe tune how or adjust the level of my talk based on the participants. Is there anyone in the audience that's currently building an RDP thin client? Thanks, guys. Okay. So what I'll do then is I'll cover RDP from a technology standpoint in Windows 8. So those of you who are currently using it will understand why Windows 8 is going to be just amazing for remote desktop, and you'll actually be able to use it in all sorts of new ways. But I'll make sure I also cover some of the very technical points for those of you who are working on building it. And I have one great demo to show our investments and what our investments are ultimately going to deliver. So I'll show a little video on that too. All right, so we'll start out with an overview of the technology changes in Windows 8, and then go into that demo video. And then I also want to bring up a bit about logo and what the Windows logo, how it's available, how you can get it for your product. Feel free to stop me at any time during the talk and ask questions. And then also afterwards, we'll have some time available. So from a timeline on RDP, I know Hope mentioned something about, where's Hope? Did Hope leave? She left. Oh, she has a government event. Okay, that sounds important. All right, so Hope, Hope mentioned XP, and a lot of people are still running XP, of course. We've made a lot of investments in Windows since XP, and in RDP, we've made a tremendous number of investments. So a lot of people who have had experience with RDP from a base configuration or from a user experience where Maybe it wasn't very fast when you tried to run remote assistance to help your mom over the modem, or you tried to use remote desktop to watch a video across the office. Those sort of experiences were experiences that we left in Windows XP. In Windows Vista and Windows 7, we developed some pretty substantial improvements in RDP. So we introduced things like media redirection, where if you play a video file on one system, the system that you've RDP'd into, that video file is then sent to your local system for playback. We added things like multi-mon support and AeroGlass, so people got that rich media experience on Windows Vista and Windows 7. So that was years ago. That was like 4 years ago, 4 years ago. I don't know if you remember, something like that. So we made a lot of improvements back then to take steps towards where we're going today and tomorrow. Then we introduced in Windows 7.1 Remote FX. Has anyone heard of Remote FX? 2, 3, 4, 5, 6. Chiba. Joe. So in Windows 7.1 or in Windows 7 Service Pack 1, we introduced Remote FX, and this has really been a huge change for our partner ecosystem. We've gone from a world where you really needed a Windows embedded client to deliver a rich experience to end users, to a world where now a small embedded processor can deliver that full rich experience. And that's been a big part of my job, is communicating to our thin client partners and working with the engineers that are developing these rich experiences. So that came in Service Pack 1, and it really took us in this first step towards bitmap remoting and server-based rendering. The next step, though, is really to deliver that experience over a wide range of networks and to a wide range of, or from a wide range of servers. Right? So in SP1, we had it for the corporate LAN. And one of the big concerns our customers have, though, is how they can help their clients that are running across WANs. So you'll see today how much investment we've made in the LAN support. Let me see if my remote control works. Ha! Look at that. Okay. Wait, it jumped me. Hang on. Make sure it's, no, okay. So in Windows 8, the enhancements we've made are really around delivering and this is just from a top level, a fast, what we call fast and fluid experience, which really equates to our new Windows 8 tablet and Windows 8 touch experience across those wide range of networks, and ultimately building on what we did in Windows 7.1 to enable a wide range of device classes. Right? So no more thin clients where people are like, hey, that's just a big x86 processor with flash. Right? These are the new zero client devices. So let's go into detail about those updates. All right, so I mentioned fast and full, what was it saying? Fast and fluid, experiences. Well, how do we get there? So a lot of different technologies coming in. We have remote effects for WAN, the wide area network enhancements. We have adaptive graphics. That's our ability to detect the network and detect the content and change how we encode based on that. Oops, back up. Okay. Media remoting, our ability to take media and deliver it compressed, so without uncompressing it, but also our ability to transcode media and send it to an end device. Multi-touch, delivering a touch experience and a multi-touch experience for a remote desktop was actually a pretty significant effort and barrier, and we developed a lot of technology to make multi-touch work remotely and give people the user feedback that they need. We've built on top of our USB redirection to make sure that things like USB bank security keys, more and more audio and video devices will work through USB. Next thing, very important, as Microsoft invests in Metro and the Metro UI, we had to make sure that we offered an ability to remote those Metro applications. We then have enhanced our support for Remote Effects clients and for Remote Effects servers. In the past, you need to have a physical GPU to run a VM. We now have a way where we can do software rendering and a soft GPU in Windows 8. That's going to allow more and more customers to deploy Remote Effects VDI. In the past, we supported just sessions and VMs with physical GPUs. We now support connection to clients. So for one-to-one blades, for connecting across the office from one machine to another, from your iPad to connect to your PC at home, all of these things are now supported in Windows 8. And then lastly, a broad range of clients. Getting the zero client support, working with our partners to build support for tablets and things like that. All right, is that exciting stuff? Okay, so what does this ultimately mean, right? So for those of you who are just using RDP for your home use and for part of your business use, it means that when you get Windows 8 and when you use Windows 8, everything is just going to work much better. I mean, that's really what it comes down to. You'll be able to connect from home and actually have a good experience, right? That in itself brings a lot of value. For IT managers, it's going to mean lower bandwidth on the corporate LAN. It's going to mean that they can allow their employees to bring in things like iPads and Android tablets, and those employees will be able to connect to secure resources on the corporate LAN without the IT manager being concerned about data being leaked out through a customer-owned device. So it actually brings a lot of value to IT managers, and brings a lot more value to the end users. Now, for those of you, the few that raised your hand and said you're building stuff, what does it mean for you guys? It means you guys got a lot of work to do. That's what it means. It means you have a good, solid job for the next few months, right? And probably a little longer, right? As you learn about this technology and as you implement it in your devices. But it also means that you're going to have better opportunity to sell your product because there are more people that are going to want the technology and more people that are going to use the technology. Oh, hang on a sec. Oh, I hit the left mouse button. Apparently not the... No? Hang on a sec. No, I'm good. I get it. So Remote Effects, for those of you who hadn't heard about it before, Remote Effects is the brand that we're using and will continue to use at Microsoft for this full fidelity experience, this rich remoting experience in Server 2012. Does everyone know we named Server? Anyone know? No? Okay, so last week, I think last week before, yeah, we came up with this incredibly interesting name, Server 2012. So that's the name of our next server product. Apparently, there's a belief by our brand marketing people at Microsoft that IT managers want really boring names for products. And so we just sort of keep following on this number thing. So anyway, I think there's a sequel 2012, there's a Office, well, I don't know what Office is going to be called, but anyway, Remote Effects, which is a cool brand, my brand, is a name for this technology, right? All right, so let's talk about adaptive graphics. All right, this is a big scary chart here. So what adaptive graphics means is that we can now intelligently look at the content that's being rendered and make smart decisions on that content based on the content type, but also based on the user's network, on how we're going to encode that content and how we're going to deliver it to the end user. So in the past, we used to look at a setting from a client. The client would tell us how it wanted us to do things. This is very difficult for customers to choose the settings appropriately. So we now can dynamically look at the network, look at the content, and actually even look at the server and the load on the server and adjust what we do to deliver the best experience for the user. So key point here is we dynamically adjust our remote desktop system based on the environment to deliver that experience. All right, so this one, let's see how my phone locked. It's supposed to tell me how much time I've been talking. Okay, there we go. Okay, so this chart shows a little bit about what we do to detect content. This is just a standard web page. It doesn't matter that it's Internet Explorer. It could be Chrome, Firefox. It could be an in-house application written by your local IT guys. And what we do now is we look at the screen and we try to identify different sections of the screen based on content type. So in the past with bitmap promoting, we used a wavelet compression and we did the best we could across all content. We gave up on that approach. And now what we're saying is we need to classify the content and then use the best we can for every piece of content. So what we'll do is we will identify high frequency bitmaps. In this case, all the text. And text has this characteristic where it's sharp color transitions. And it doesn't matter if it's Roman characters, if it's Chinese characters, Japanese, as long as it has high contrast transitions and very few colors, we can apply a special codec we have called Remote Effects Text, which will deliver very sharp lines in very low bandwidth. So we quickly identify which portions of the screen are text and include and encode it with text codec. Then what we do is we identify anything that is a natural or synthetic image, and we deliver that through a Remote Effects Callista codec, which is a Remote Effects image codec. So natural and synthetic images have certain qualities, right? Natural images, you can use wavelet, and you can throw away data that the human eye can't see. Do a very good job compressing them. If you use the same wavelet on the text, it would just create all sorts of artifacts, right? So we intelligently identify the images, encode those. And then lastly, what we do in 8 is we'll identify flash or video content, right? Like the pretty girl selling cell phones here. That's a flash video. We will identify that as video content and transcode that to H.264. So collectively, our high-speed block classification algorithm combined with our multiple codecs deliver better images in lower bandwidth to really drive this adaptive graphics experience. Okay, if that wasn't nerdy enough, we get even nerdier. Okay, now from an image compression point of view, we've enhanced our image compression algorithms to allow progressive rendering. Anyone know what progressive rendering is? Okay, yeah, a couple people, lots of people. Anybody totally bored with this? Raise your hand if this has nothing to do with you or your job. Oh, come on. You're being shy. Okay. Bear with me, or there's Coke available somewhere. All right. Progressive rendering is when you can take an image and start drawing the image in front of the user when only 1/3 of the data is available. What this allows us to do is it allows us to give actually more frames to the user when the screen changes a lot. So while it looks like in this demonstration is about building one image 3 times, in reality, it's all about building different images only 1/3 of the way. Now, this example shows 3 different steps of an image being delivered. These are actually, this is not actually from our product. These are artificial Photoshop blurs. Because if I were to show you what 1/3 of the data looks like, you would just basically see this last one, and it would be hard to see. Because really, when you deliver the first third of the data for a wavelet image, you really deliver almost all of the experience for the user. So what users will get with progressive rendering is something like if they hit a window maximize, and in the past, maybe you could only deliver 4 frames per second over the same amount of bandwidth, we now can deliver 12 frames. So users will just get this fluid experience, and they won't notice any degradation of video or degradation of experience. And then whenever the image becomes static, before they can perceive anything, it will snap to the sharpest image. Now, just in case they're on a slow network, or just in case something goes wrong, because we use codec diversity, things like text will always be delivered in the sharpest way, right? So you get progressive for those images, but you get text really sharp, so you never have to have a situation where the end user's eye is trying to focus on blurry text. If you do that, it really causes an annoyance to the customer or the end user. They may not know why they're annoyed. They may just get mad and yell at their coworker, right? But it's because their eyes are trying to focus on something they can't focus on, right? So by always using Remote Effects text for text images, we can always make sure they have that sharp image. All right. Now, I'm sure any of you guys have read Engadget. Most of you actually maybe have played with the preview, customer preview of Windows 8. You know that Microsoft is putting a lot of investment and time into the new touch interface and the new Metro style user interface. Same as in Windows Phone, it's in Xbox, and now it's in Windows 8. It's critical that remote desktops are there to support these apps in the future. You know, you can imagine nursing applications where a nurse is carrying a tablet and needs to be able to interact with the touch interface. In those environments, all of that data should be stored on a server, and people will want to use the Metro interface for it. So it's really important for your clients, for you guys, building devices that you have Metro capabilities for your devices for those sort of scenarios and for the new apps, right? And that's really about supporting touch-friendly UI, making sure in your client the UI is capable of being driven by touch, making sure you support touch remoting, and it's not easy. It's not horribly difficult, but we have a lot of guides and information to help you do it. But you need to be able to support touch in a way that people have that fluid experience with the Metro desktops. Lastly, an important piece here is we have this integrated for remote app. So individual applications can be able to be delivered through remote effects with the touch UI. All right, so that's a lot about the codecs and the changes we made in the codec support and how that's going to deliver. Does anybody have any questions on the codec stuff? Anything? No? Okay. We made a lot of these changes in the codec actually because we wanted to deliver a good experience for the wide area network. A lot of you may be familiar with Citrix. Citrix is a partner and also a competitor of ours from a technology standpoint. They have traditionally done quite well across the wide area network. And our first release, we focused on the local and area network, but and our first release of remote effects. With our second release, we really put almost everything we had into delivering this amazing wide area network experience, and I'll talk to you a little bit about that. Wide area networks are huge challenges for applications that need to appear to be real time to a user. So if a user is doing like a pinch zoom on a photo, they need to have immediate feedback when they move their fingers, and they shouldn't have to know or care about their internet connection, where their server's located. But what they should experience is a fluid experience as if it was local to the machine, right? Well, that has to be delivered across networks that may have very long latency. So by the time that signal reaches the server, maybe 100 milliseconds or even longer. This is ping latency of 100 milliseconds. That's only a 50 millisecond latency. We're actually designing and testing for closer to 200 milliseconds. So it means you need to get the input from the user, deliver it to the server as quick as possible. The server needs to react, render, do the block classification, encode, pass those packets back, and the device needs to render those packets as fast as possible for the user. We have to deal with things like packet loss. In America, we have, I fly between my office in Silicon Valley and Redmond, and we have Wi-Fi available on our planes. So it's pretty common for people to have wireless connections on airplanes. One of the problems with the Wi-Fi in the plane, though, is pretty significant packet loss. We need to make sure that people have decent remote experiences, whether or not they're accessing the remote desktop from like a 4G modem, a 3G modem, or if they happen to be sitting on an airplane seat and they need to update a database before they land, right? We also need to work in very limited bandwidth, and that's where the codecs come in, that limited bandwidth piece. So tough conditions. So how do we do it? We take the codecs and we use these new codecs to deliver the same experience in sometimes 1/10 the amount of bandwidth, right? So 10% of the bandwidth that we used in RDP 7.1, we can use in RDP 8 to deliver the same experience. That's the key first part of delivering this over low bandwidth links. Second piece, right? We have to make sure we integrate it with RDP gateway so people who are outside the network can actually access it inside the network. We got that. We finished that work. Then we need to provide a great transport to deliver over lossy networks. TCP windowing doesn't allow us to deliver large amounts of bandwidth over lossy networks. So we moved to UDP and forward air correction to allow us to deliver that kind of high bandwidth experience over lossy. This is going to be really critical for remote workers. It's going to be, yeah. We use UDP for audio and video experiences. So for the type of data that if it's delivered late, it doesn't matter, that goes over UDP. But we still do command and control over TCP. And what it means is things like USB still require TCP and are limited to kind of the bandwidth we can get out of a TCP connection. But key press is everything else is, of course, over TCP also. The people who are going to get the most benefit from this is going to be branch office workers and then the mobile workers, really. And then for all of you, it's going to be when you're connecting from home. You're going to get a lot of the value out of these. Here's another big, scary, fun chart. And in fact, this goes back to, I think, the exact question you had. We now can detect the type of network we're in. When we detect a lossy network, like on a WAN, what you'll see is this TCP transport, which is our default in the corporate LAN. We'll go ahead and bring up a separate UDP transport and then shift the virtual channels for audio and video across that. So it means things like for your implementation, dynamic virtual channels are very important. If you don't already have dynamic virtual channels implemented, it's probably one of the first things that you're going to want to work on. And then we'll run those virtual channels on top of UDP and with our forward air correction technology to deliver that, the highest bandwidth pipe, I guess, to the rest of the system. Demo time. Okay. Let me show you what this means. So I mentioned earlier that my team, I fly back and forth between Silicon Valley and Redmond. So my team is actually in 3 locations. There's the team in Silicon Valley, where we do virtual GPU, we do the Callista codec, and then the team in Redmond where we do a lot of the core protocol work. But then lastly, there's the team in India where we do the licensing work, we do the internet gateway work, so we do a couple of other things there. So this was done by our guys in India. And what you're going to see is a connection between Windows 7 with remote effects and then Windows 8 with remote effects across a wide area network and the difference between the experiences. So the network characteristics, incredible latency here, quarter of a second latency, 1.5 megabits. This is a 3D engineering application. So Windows 8 on the right, Windows 7 on the left. You can imagine an engineer in the field trying to manipulate a device. The Windows 8 experience, you can manipulate and twist, right? And get enough, maybe the engineer is looking at some part and he's trying to decide if there's a conflict in the design or if it's a manufacturing error. The engineer has enough of an experience. Let's see if I can, hang on a sec. The engineer would have enough of experience to be able to deliver, to actually check that part and see if there's conflicts and really identify the problem, right? With Windows 7, it would be too difficult for the engineer to manipulate that 3D item. So the next thing we're doing is we're going to look at a simple PDF scroll between Windows 8 and Windows 7. And what you're going to see here is really the power of the codec diversity kicking in you'll see how the images and combined with the text codec allow us to deliver a much more fluid experience on scroll. So Windows 8 is always the one that looks usable, just for reference, right? The one that looks better is Windows 8. Here, all the text, everything is encoded with text codec. These natural images are encoded with the image codec. So the text renders right away really sharp. The image codec will deliver the images using the remote effects codec, so they'll be progressively built. Allows the user to have a much more fluid experience moving the chart. Okay. And then, I mentioned we can, if you remember the screen that was broken up and there was the girl selling cell phones, right, for T-Mobile. We can detect video content, and we do it very quickly, and we'll then build up a H.264 channel, transcode that content, and deliver it to the client. So that's new in Windows 8. Windows 7 didn't have that. So you'll see here the difference between 7 and 8. I do have a little bit of audio coming out of my laptop. The audio only follows Windows 8 because the Windows 7 would just be too choppy. And this is a, so here, there's a little audio. So you can see the experience, while it's still a remote desktop and it's not perfect. Let me mute this here. So it's still a remote desktop, right? And we can always improve. We're always going to do better, every release and every release. But the experience in Windows 8 is completely usable and watchable, versus the experience for Windows 7 is still quite fragmented, right? And I do want to remind you, though, that this is across a wide area network from India to Redmond with a quarter of a second latency, tremendous amount of latency, constricted to 1.5 megabits. If we did this experiment on a corporate LAN with 100 megabit or gigabit link, both would look identical, right? So Windows 7, we designed it for the LAN. It works great on the LAN, but where we really wanted to make those investments and improvements is across that wide area network. So now we're going to look at the bandwidth utilization differences between using it on a LAN with Windows 7 and Windows 8. So in the prior stuff was all about from India, low bandwidth link. This is high bandwidth, low latency link. Let's take a look at Windows 7 bandwidth for a high definition video. You can see here, to deliver the experience, we're touching almost 60 megabits of data. So moving a tremendous amount of data to deliver that experience. With the exact same experience in Windows 8, we're looking at 1/10 that, so 4 megabits. And this really is, a key part of delivering that that great multimedia experience across the WAN. Of course, if you don't have 4 megabits, you'll still get a good experience, but what you'll get is you'll get probably 1/3 the frames. Yeah.
What about the CPU? Does Windows 8 take more resources to the data?
Yeah, so on the server side, we do use more CPU. I'm sorry. Oh, yeah, repeat the question. Yeah, the question is, what about CPU? And if Windows 8 uses, or Windows Server 2012 in this case, uses more CPU. It depends on the user case. But we can and we will use more CPU when delivering multimedia experiences. We use less CPU when delivering a lot of the basic task and information worker experiences, because text with the text codec is a very low compute complexity codec. It's actually pretty fast. that allows us to save CPU. But then when we're doing things like transcoding H.264, we do use more. We've worked closely with Intel and AMD, and they've helped us hand tune the code to do the encoding. The other thing that we've done is we have worked also closely with NVIDIA on doing compression on the server side. So we use more, but we've done, I think, a lot to make use of the technology that's in next generation CPUs that are actually Ivy Bridge, I think, just came out, right? So we use some technology in Ivy Bridge, and we have some capabilities to use technology in the following generation that'll make that even better. I mentioned that we can detect video and then transcode it. This is an example of that, where we can take a look at the screen, find silver light, and it really doesn't matter what it is. If it's iTunes, if it's Hulu, if it's in this case HTML5, we can identify regions of video, transcode it to H.264, and deliver that great experience. So, in the past with media remoting, it really required that customers were running Windows Media Player. Now we don't require that. So any content that's rendered on the screen that appears to be video, while it's video, it will get transcoded into H.264. As soon as it stops, or if I hit pause, then it flips back into the remote effects codec as static, and as soon as someone hits play again, immediately H.264. How do we identify what it is? We're using some technology that was developed by Microsoft Research in Beijing over the last 7 years for high-speed image classification. And they have some proprietary algorithms that can look at bitmaps and quickly determine what they are. So it was something that we actually tried to get into our first remote effects, but it was still a little immature. And then this is really the first time we're bringing it to market. No, it's done when right after we render a frame buffer, right? So when a frame buffer is rendered, we capture it at a very low level. The question is, at what level does this happen, right? So we actually capture it at a low level, lower than like a video driver level, and then we compress it at that point and then hand it back.
H.264 where the server we do the transcode.
Yeah. So if the media is H.264, we will render it on the server side, and then we will have to identify it again as video and transcode it to H.264.
Okay.
So this makes it a little easier for clients, because clients can then only work with a single, then clients may only implement a single profile of H.264 and not have to worry about the many profiles of H.264 that are out there. So everything is sent through H.264 base. It also allows us to capture things like overlays, which can be a problem when you're passing uncompressed or compressed H.264 without transcode. I believe the demo used IE9 for Windows 7 and IE10 for Windows 8. But because of the way Remote Effects is working, it's really independent of the browser that's doing the rendering. And we could have given the exact same demonstration with Chrome. So this last piece is something that I think is actually important for everybody. I covered a lot of the technology that's going into RDP 8 for Windows Server 2012. You saw the codecs, you saw the changes in the network. One thing that's going to be important for you, if you're a user, when you're looking for thin clients, it's going to be the Remote Effects logo. If you're building thin clients, it's going to be the Remote Effects logo, right? Because what we find is that our customers, when they look at a wide range of clients that are available on the market, they want to know which clients work well, and they often ask our sales team which clients should they use. We created the Remote Effects logo with the hope that it could help the industry identify devices which work well with Remote Effects. So that's the Remote Effects Enable logo. There's already, I believe, 20 or 30 devices out there that have this logo, and there's going to be more coming on the market in May and June. This is available for any thin client and zero client device that supports Remote Effects. It's not available for software applications. So if you build an iPad app, you can't get a logo yet. The key requirement is it needs to support Remote Effects out of the box. So when somebody takes your client and plugs it in, it needs to be a Remote Effects capable client. Then in addition to that, we need support for all the Remote Effects scenarios or user cases, virtualization and session host. We need to have a certain level of performance. So we believe that customers that are running Remote Effects expect a level of experience that's equal to about 15 frames per second at 1280 by 1024. Now, many clients deliver faster experiences, but that's really where we're drawing the line for logo. And then right now we don't have a requirement for USB remoting, but we're considering that for Windows 8. All right, now what do you get in the client kit? We've got some data sets for validation of the codec implementations. So as you work on your Remote Effects codecs, you need to be able to validate that they actually render correctly and there's no rendering errors. We have kits, we have data available for that. We have performance tools, which will measure from the server side the performance of the thin client. So everybody who's got a logo, they've submitted their performance information, and then we have a bunch of additional documentation and a certification forum with a bunch of steps that need to go through, a reasonable number of steps that need to go through to get that logo certification. Some of the examples of those steps, we do things like RDP connectivity tests, making sure that a device will be robust with network connections. So if there's if the device loses an Ethernet link, we expect the device to be able to auto reconnect, things like that. Those sort of tests are there in the kit and enforced for Remote Effects. We have some simple tests doing scroll, AV sync, things like that. We really want to make sure that users, when they buy a Remote Effects logo device, have the Remote Effects experience, and that's why the program's there. In order to build the device, you need to make sure you do have a certified codec implementation, or you need to build your client from certified implementations. So if you're looking at building a Remote Effects client, use semiconductors that are already verified and work with a semiconductor partner on the verified chips. Send an email to our logo kit address to get the link to the kit, and then you submit logs to Microsoft, and our test team will go through those logs and issue the logo. Let's see. So main thing, test your codecs, test your thin clients, and ship your product. And then once again, the logo kit email address is really the best source for resources. I can also answer any questions today about the kit and what's available. All right, so the key point is for your users, all your users, for Windows 8 to Windows 8, you guys are going to have great remote desktop experiences. For those of you building thin clients, you have some work to do, but it's going to deliver a great experience to your end customers, and the customers are going to want to buy your clients with 8, right? Because these guys are going to want to deploy over WAN. They're going to want to be able to support these kind of scenarios. We still allow 7 connections. 7 connections will work great, actually a little better than they work in Windows 7 with Remote Effects, but they won't deliver the wide area network experience. They won't deliver that low bandwidth, high fidelity experience. So it's really important to consider doing the implementations. All right, so are there any additional questions?
So when you say adaptive graphics, so when choosing the codec, can the server negotiate with the client what kind of codec the client supports?
The server will negotiate 3 different profiles of codecs. One is the Windows 7.1 or RDP 7.1 profile. So if you have an existing client, we'll negotiate that. Then we have a concept of thin and zero, or thin and thicker zero clients, right? So we have 2 additional profiles. They all require text. They all require H.264. Okay. Oh, wait. Sorry. H.264 is independent. They all require the text codec. They require one of the Remote Effects codecs, either the Callista V1 or Callista 2 with progressive, and then you can negotiate H.264 independently.
Okay.
So there is kind of a menu, but unlike in the past where you can basically pick anything you want and the server will handle it, we only have 3 real profiles and technically 2 variants, so 6 profiles, 6 choices.
Software requirement for compliance with the RDP. How about the hardware requirement for this? Do you have any suggestion?
Yeah, so I would say it depends on what kind of product you want to build, but we have semiconductor partners that have chips already available for Windows 7 and for Windows 8. So companies like ASpeed here in Taiwan has a chip that they're talking about pretty soon or already. Companies like Morningstar, Texas Instruments, Cloudium, all these companies have chips specifically designed for thin clients. If you want to run a general x86 processor, that works as well. In that case, we work closely with AMD on their Fusion E series, and they've optimized implementations for Remote Effects. But nothing is as low power and as fast as the dedicated hardware, which you get from companies like the ASpeed TI, Cloudium MStar sort of companies. So, and I'd be happy to go over those chips and those options with you. Oh yeah, so Brian's also going to be available this afternoon to, actually not just this afternoon, all week. Brian's here all week. Raise your hand again, Brian. Okay. So Brian's here all week, and in fact all year he's available at the Doc Help alias. So Brian, for protocol questions, Brian's really a great resource to have and to know. Even if you don't have questions this week, I would encourage you to meet Brian and talk a little bit about what you're doing, and know so he knows who the other individual is across the email when you eventually ask him questions.
Have the engineer here. We brought the RDP protocol test suites. If you are interested to take a look, we offer the one-on-one session tomorrow and the Friday. You can come take a look.
Yeah, I should mention that. Yeah, so in addition to the logo resources, our team in Shanghai has been working hard on the RDP protocol test suite. And we have 2 sessions, right? So 2 sessions tomorrow morning on the RDP client test suite Protocol Client Test Suite, right? And those are great tools to look at as you're developing your thin client. It's a test server that you can connect to, and it will help validate the exchange for BCGR and remote effects and eUSB. So all those, I think, and the EVOR, right? Yeah, so all these are all RDP specs for those of you who are not implementing RDP. Yeah, the test suite's a great resource. Thank you. I don't know how I missed that. And tomorrow morning you're going to hear about that too. All right. Any other questions? So I am going to be here. I'm here today and Thursday. I am available for meetings this afternoon. So for some of the RDP guys, if you don't necessarily want to listen to the Exchange Protocol talk and you'd like to talk about some RDP stuff, we can meet this afternoon. Unfortunately, I'm not going to be here on Friday. I have to leave a little early. So today and tomorrow I'm available, and I'd definitely like to get together and meet.
好，谢谢 ，Thank you, Rob.